Good morning, everyone. Today, in the next session, we are going to see how we can take decisions in a C programming language. As we know, C is a language where we can perform various tasks. Till now, we have seen the basic structure, how to give values, and how to get inputs and outputs. Next, we will see how we can take decisions and we can make different types of operations based on the decisions. So, let's see how we can do decision making in C. Controlling your code. An introduction to C's decision making statements, the foundation of dynamic, intelligent programs. Programs rarely follow a single straight path. They need to react to user input, compare values, handle different conditions, and choose the right action at the right time. Decision making statements make that possible, turning static instructions into code that can respond intelligently to real world situations. In C, these statements help solve problems like validating input, directing program flow, handling multiple outcomes, and preventing errors before they happen. They are essential for building software that can adapt instead of simply repeat, whether you're writing a simple calculator or a more complex system. In this session, we will learn how C uses conditionals to control execution, how to write clear branching logic, and how to combine these tools to make program more flexible, reliable, and useful. So decision making C control statements is divided into three parts. One are the conditional statements, two are the iteratives or looping statements, and three are the jump statements. So we will look how the control statements works. What are control statements? Decision makers. Control statements evaluate a condition and decide which path to take. In C, a condition is treated as true when it evaluates a non-zero value and false when it evaluates to 0. They often use relational operators such as greater than, less than, equal to, and not equal to compare values. For example, if age greater than equal to 18 checks whether someone is old enough to vote. If the expression is non-zero, the statement runs, otherwise it is skipped. Dynamic behavior. Without control statements, a program follows a linear execution path. Statement 1, then statement 2, then statement 3 every time. That works for simple tasks, but it cannot adapt to changing data. Control statements and branching with if and switch, repetition with for, while, and do while, and conditional logic that changes behavior based on input, state, or results. This is what makes program responsive instead of rigid. Building blocks. In real C programs, control statements appear everywhere. They validate user input before a calculation continues. Check for errors when opening files or reading data. Drive menu systems that let users choose actions and control game logic such as scoring, collisions, turns, and win or lose conditions. They are the foundation for handling the real world situations where the correct next step depends on what just happened. The power of conditional execution. Think of a program as a recipe. Normally, instructions run top to bottom in a straight line. But if you need to skip a step or choose between two paths, that's control flow. The ability to direct the program's execution path based on conditions that are evaluated at runtime. Condition is true, execute the block. Condition is false, skip or branch elsewhere. So let's see some key definitions. First one, condition. An expression that is evaluated to decide what happens next. So a condition is something which helps us to take a decision, or it will help us to guide to take a decision. Next, control flow. The order in which the program instructions are executed. So how the statements should be executed, or what statement should be executed after what. So that is control flow. Branching. Choosing between two or more different execution paths. So if we are taking decisions and if we are having too many options, to take one option is called as branching. Relational operators, symbols such as greater than, less than, equal to and not equal to that compare values. True or false. In C, true means non-zero value and false means 0. So in C, true or false is basically a Boolean value where true means 1 and false means 0. Execution path, the route a program follows as it runs through statements. Types of control statements in C. So as I said earlier, there are three types of control statements: decision making, looping and jump. Decision making includes if else, else if ladder and switch. Looping statements include for, while and do while. And for jump statements, it includes break, continue and go to. Decision making statements let a program evaluate a condition and choose what happens next. They include if else, else if ladder and switch. Next are the looping, for, while and do while to repeat the code blocks. Jump, break, continue, go to, alter, flow mid execution. Control statements guide how a C program moves through code. Decision making chooses paths, looping repeats action, and jump statements change the flow directly. So first is the simple if statement. Execute a block of code only if a condition is true. So among the decision making statements, the first one is a simple if statement. So in if statement, we will give a condition, and only if the condition is true, the remaining block code will be executed. Here we don't have an else option, which means what if the condition is false, we don't have any code or statements to be executed for that. Syntax: if condition within braces, code runs when condition is true. Example: int score equal to 75. If score is greater than equal to 50, printf you have passed. So in this example, we are taking a value, a score as 75, which is an integer value. Now in if we are giving a condition, we are giving a condition, score should be greater than or equal to 50. If my score is true, then only it will go execute the code within the braces, and if my condition is false, it will just break the condition. So my score, initially the value given is 75. So if score greater than equal to 50, which means 75 greater than equal to 50, and the condition is true, so the output will be printed, you passed. Next is the if-else statement. Choose between two paths based on a condition. So here is the second type of decision making, where we are having an if condition for which we have both the statements, what if the condition is true and what if the condition is false. So the syntax: if condition within the braces, statements run if true, else within the braces, statements run if the condition is false. Example: int age equal to 17. If age greater than equal to 18, within the braces, printf, you are eligible to vote, else printf, you are not eligible to vote. So in this example, we are taking a value, a age, as 17, and we are giving an if condition, first one, where age is greater than equal to 18. So if my age is greater than 18, then I am eligible to vote, else I am not eligible to vote. So initially the value given is 17. So if age greater than equal to 18, which means 17 greater than equal to 18. Now since my condition is false, this true part will be skipped and directly the execution will start from else. So in else, I am given with the print statement, you are not eligible to vote. So my output for this sample code will be, you are not yet eligible to vote, because my condition age greater than equal to 18 is not satisfied because my initial value of age is 17. Next is controlling program flow, key takeaways. We have explored the core decision making statements in C that made programs more dynamic and responsive. Conditional execution: if and if else, let your program choose between paths based on a condition. Multi-way choices: else if and switch handle multiple conditions cleanly. So how else if and switch works, we will see in the next session. Dynamic programs: these statements help C program react to inputs and changing conditions. The broader control flow landscape: decision making is just one part of the control flow. Thank you.